All right. Hello, everybody. Welcome back to the stream. Hope you're having a wonderful day so far. We are in a little bit of a different setup than typical here. I appreciate you guys for joining me. How is it going, everybody? Welcome in, welcome one, welcome all. All right. All right, cool. We are on live on Twitch and YouTube here. I am in a different setup than normal today, my friends. I am over at my lady friend's house. We are, or at her mom's house, I guess, for where she stays during the week for work. I'm just visiting here this weekend. It's my turn to kind of come up and take the load off of the travels. So, and we all of our inventory is here for our business and stuff. So, we got to do some little bit of business work. Looks like it might be a little bit choppy here. Let me see settings. Let me put this to Hello, Tim. How's the connection? Is it spotty or is it okay? If I need to, I can go on live on Twitch. I think that might be alright. It might not be. Yeah, they have this cutout here that's kind of funny looking. We might need to stop the stream on the Twitch, it looks like. Um, $15,000. Let's go ahead and stop the Twitch. I don't think it's gonna be enough fast enough. All right, I stopped the Twitch here. Yeah, that seemed to have done the trick. All right. It was the Twitch after all. The multi-stream was lagging. My girlfriend's mom's internet's not fast enough. It's okay. All right, for those that are new here, or that are we're in a different setup than normal. We are here at my girlfriend's mom's house, just visiting for the weekend. This will be probably today and tomorrow's stream in the same setting as we read through and complete Git Chapter 4 and Chapter 5. So let's go ahead and get this started. How about, yeah? So let's go ahead and get this loaded up. We need to get the chat going, yeah? I am a little bit earlier today. We are going to go see a movie tonight. That's why I'm a little bit earlier. It might be a little bit more of a shorter one. I probably will do a double feature and come back on live for a I'll come back live for an additional probably late night tonight. There we go. That's fine. That look okay? Yeah, that looks okay. Oh, a little bit further. Getting all close to the screen probably looks funny. Right there. Yeah, that looks good. All right, let's go ahead and get this show on the road, you guys. Thanks so much for being here and hanging out with me. I really, really appreciate it. Let me know if things are cut off on the screen or if the audio is weird at all. I'm in a different setup, so I'm trying my best to um, kind of do things off of a normal setup. The aspect ratio is a little bit different when I'm on my laptop, so I have to adjust things a little bit differently here. So let me know if things are too cut off. It shouldn't be that bad. Only the terminal should really be cut off, and so it should be okay though. Okay, let's get this started. All right, so let's go pro git. We want chapter 4, right? How does that look? It's a little cut off. I might have to remove the chat today. Well, let's see. How can we organize this? Can we put our book over there and our notes on the right? And go new folder. Chapter 4. Chapter 4 notes.md. Okay, now we're in. Let me grab my phone, make sure that looks good. I would like to multi-stream onto Twitch if I could. So it's kind of frustrating, but I don't think the internet's going to allow us to. Oh. Switch over to our stream here. Okay, that'll work. That's fine. All right, I got the chat loaded up here on the side so I can see you guys. Neighbors' keys. Legally mandated to wear that shirt. I do get a lot of compliments on this shirt for being so simple. They think it's like funny and fun. People do say though I'm forced to wear it. All right. All right, you guys, we are reading Pro Git chapter 4 today. It's not as long of a chapter as yesterday or the day before, so hopefully we can get this one done in about an hour. I only have time for about an hour stream right now, and then I'm going to go see a movie with my girlfriend and her mom and her sister, and then I'll probably come back for a late night coding session on the Small Business Manager project where we'll finish up the balance sheet tonight. So let's go ahead without further ado and get on into the reading. If you guys would like me to change up the display here of how my notes are, if you guys can't see or if things are cut off, please let me know. I will adjust it appropriately. All right, Pro Git chapter 4, Git on the server and the protocols. Okay. So what is chapter 4 called? Git on the server. Okay, so chapter 4, 4.1, Git on the server, the protocols. At this point, you should be able to do most of the day-to-day tasks for which you'll be using Git. However, in order to do any collaboration in Git, you'll need to have a remote Git repository. Although you can technically push changes to and pull changes from individual repositories, doing so is discouraged because you can fairly easily confuse what you're working on if you're not careful. Furthermore, you want your collaborators to be able to access the repository even if your computer is offline. Having a more reliable common repository is often useful. Therefore, the preferred method for collaborating with someone is to set up an intermediate repository so that you both have access to and push and pull from that. So we'll go intermediate repository, a remote repository where collaborate can work on the same project no matter the time or location. All right. You could go see the Minecraft movie. No, I don't think we're seeing the Minecraft movie tonight. I think I can't remember what we're gonna go see. If I ask my girlfriend the title of it one more time, though, I might be in trouble because I've already asked like 4 times and I can't remember again. So if I ask one more time, I might be done for. Don't want to push my luck. Okay. Running a Git server is fairly straightforward. First, if you choose which protocols you want your server to support. First, you choose which protocols you want your server to support. The first section of this chapter will cover the available protocols and the pros and cons of each. The next sections will explain some typical setups using these protocols and how to get your server running with them. Last, we'll go over a few hosted options if you don't mind hosting your code on someone else's server and don't want to go through the hassle of setting up and maintaining your own server. If you have no interest in running your own server, you can skip the last section of the chapter to see some options for setting up a hosted account and then move on to the next chapter where we discuss the various ins and outs of working in a distributed source control environment. We might have to go upstairs here. Yeah. No, I could probably go upstairs. I'm just reading my book here. Okay. A remote repository is generally a bare repository. So a bare, right? A Git repository that has no working directory. That has no working directory. Because the repository is only used as a collaboration point, there is no reason to have a snapshot checked out on a disk. It's just the Git data, in the simplest terms, a bare repository in the contents of your project's.git directory and nothing else. Here, let's go upstairs real quick. Got my keys jangling. The janitor. That's what my cousins call me with my keys on my keychain. They say I am the janitor. But then when the trend started going towards everybody putting their keys on keychains, everybody started doing what I was doing. And now it's all cool, so who's laughing now? All right, we're back here. In our norm, we are back. We're good here. Now we're up here in my girlfriend's room. Hey, smoking. Fun fact, actually, I called out of work today. I had some work I had to get done on my small business and stuff. I took the day off. I drove up to the city where my girlfriend's at, where we have our inventory, and we were logging some clothes and getting things situated via our inventory and all that. So I was able to, but in general, it's honestly, I don't do a lot else, my friend. This is all I do. I go to work, I make my money at work, I come home, I stream, I teach myself code, I repeat. So it does come at a price a little bit, you know. Okay. Cool. So let's bring this over so that it's not cut off. How about, yeah? Where do we have to bring it to so it's not cut? Let me see. probably like here, I would say. Any new inventory, Tim? You guys got the jokes today. You guys are funny today. Minecraft movie. All right, here we go. Let's keep moving. We got to keep moving. A Git repository has no working directory because the repository is only used as a collaboration point. There is no reason to have a snapshot checked out on disk. It's just the Git data. The simplest terms, a bare repository and the contents is the contents of your project's.git repository directory and nothing else. Let's go ahead and crack the window here. Like that. Okay, we're good. All right. The protocols. Okay, Git can use 4 distinct protocols to transfer data: local, HTTP, secure shell, and Git. So we'll say 4 main protocols. Number 1 is going to be local. Number 2 is going to be protocol. Number 3, not E, number 3 local HTTP, sorry, not protocol. Secure shell. And number 4, right, Git. Cool. Local protocol. The most basic is the local protocol, in which the remote repository is another directory on the same host. Okay, so local, the remote repository is in another directory on the same host. This is often used if everyone on your team has access to a shared file system, such as an NFS mount, or in the less likely case that everyone logs in to the same computer. The latter wouldn't be ideal because all your code repository instances would reside on the same computer, making a catastrophic loss much more likely. If you have a shared mounted file system, then you can clone or push to and pull from a local file-based repository. To clone a repository like this, or to add one as a remote to an existing project, use the path to the repository as the URL. For example, to clone a local repository, you can run something like clone and then the path. You can do this, or you can do this, clone file into this path. Git operates slightly different if you explicitly specify the file // / at the beginning of the URL. If you specify the path, Git tries to use the hard links or directory copy the file it needs, or directly copy the file it needs. If you specify the file, Git fires up the process that it normally uses to transfer data over a network, which is generally much less efficient. The main reason to specify the file prefix is if you want a clean copy of the repository with an extraneous reference or objects left out. Generally, after an important... Hold on, someone's vacuuming. Okay, we're good. It's kind of a cute background. Huh, distracted funny. Thanks for coming in. You just got off work. Nice. How you doing? How was work today, guys? Let me know what you guys are studying and working on. How was your guys' day today? How are your guys' classes going? If you guys are in finals, let me know how finals are going. If you're part of the early crew, leave a thumbs up on the stream. Thank you truly for being here, you guys. I really, really appreciate all you guys joining me here. Let's see if we can. So let's try the Twitch again here. Let's see if the Twitch will work now that I'm closer up to the router up here. Now it really starts to drop my frame rate. I think we might have to call it on the Twitch for while we're here, unfortunately. Which kind of stinks. The Twitch was kind of popping off lately. Let me see. Is it lagging? No, we're not lagging on there. Is it lagging on YouTube? How about YouTube? Yeah, it's lagging on YouTube. It's a bummer. All right. The Twitch is not going to work while we're here. No worries. It's all right. I work at a clothes store and they gave me 30 free Raisin Cane tenders. Nice, dude. So I'm eating it for 30 of them? Jeez. You got chicken fingers for days. Nice, dude. Raisin Cane's chicken fingers are so good. They're probably the best I've ever had. Okay, so from locals from the same host, you can use this here, this git clone. Right? Or you can use this. Or you can do this. Oh. Right? And then we'll say that this thingy here, this file, is my keyboard too loud? It might be a little too loud. I can hear it in the background. I'm going to turn this down, I think. Let's turn it down to like 2.5. Oh yeah, for those that aren't new, I'm just visiting my I'm at my girlfriend's place today. In the different city. She's just in a city about an hour and a half away, and so I am visiting her for this weekend rather than her coming down to me, trading off a little bit. If you specify the file at the beginning of the URL, if you just specify the file, Git tries to hard link the direct copies it needs. If you, so this, I'm not sure what this does, is if you want left out, like so, that if you want file path, repo file path, you want a clean copy of the repository. Okay. To add a local repository to an existing Git project, you can run something like this: git remote add that. Oh, gotcha. Then you can push to and pull from that repository via the new remote name local project, as though we were doing some work over a network. The pros. The pros of a file-based repositories are that they're simple and they use the existing file permissions and network access. If you already have a shared file system which your whole team has access, setting up a repository is very easy. You can stick the bare repository copy somewhere everyone has shared access to and set the read-write permissions as you would for any other shared directory. We'll discuss how to export a bare repository copy for this purpose in Getting Git on a server. This is also a nice option for quickly grabbing work from someone else's working repository. If you and a coworker are working on the same project and they want you to check something out, running a command like git pull with this path is often easier than them pushing to a remote server and you subsequently fetching from it. The cons. The cons of this method are that the shared access is generally more difficult to set up and reach from multiple locations than basic network access. If you want to push from your laptop when you're at home, you have to mount the remote disk and which can be difficult and slow compared to network-based access. It's important to mention that this isn't necessarily the fastest option if you're using a shared mount of some kind. A local repository is fast only if you have the fast access to the data. A repository on NFS is often slower than a repository over SSH on the same server, allowing Git to run off local disks on each system. Finally, the protocol does not protect the repository against accidental damage. Every user has the full shell access to the every user has full shell access to the remote directory, and there is nothing preventing them from changing or moving internal Git files and corrupting the repository. HTTP protocols. Git can communicate over HTTP using two different modes. Prior to Git 1.6.6, there was only one way to do this, which was very simple and generally read-only. In version 1.6.6, a new, smarter protocol was introduced that involved Git being able to intelligently negotiate data transfer in a manner similar to how it does over SSH. In the last few years, this new HTTP protocol has become very popular since it's simpler for the user and smarter about how it communicates. The newer version is often referred to as the Smart HTTP protocol and the older way as dumb HTTP. We'll cover this newer Smart HTTP protocol first. Okay, so you have a Smart HTTP. Operates very similar to SSH or Git protocols, but runs over standard HTTPS ports, and you can use various HTTPS authentication mechanisms, meaning it's often easier on the user than something like SSH, since you can use things like username password authentication rather than having to set up an SSH keys. It is probably it has probably become the most popular way to use Git now, since it can be set up both serve anonymously like the Git protocol, since it can be set up to both serve anonymously the Git protocol, and it can also be pushed over the authentication and encryption like the SSH protocol. Instead of having to set up different URLs for these things, you now use a single URL for both. If you try to push and the repository requires authentication, which it normally should, the server can prompt for a username and password. The same goes for read access. In fact, for services like GitHub, the URL you use to view the repository online, for example, github.com/repo, whatever, username and repo, is the same URL you can use to clone and, if you have access to, push over. Okay, a single URL link that is synced to a remote repository where users can push and pull from said link. Now the dumb HTTP, right? We almost at 1660. 1660. Thank you guys truly for hanging out with me and joining me here and breaking us over the 1660 mark. You guys are awesome. We're climbing up, boys. Okay. dumb Git. If the server does not respond with the Git HTTP smart service, the Git client will try to fall back to the simpler dumb HTTP protocol. The dumb protocol expects the bare Git repository to be served like normal files from the web server. The beauty of dumb HTTP is the simplicity of setting it up, because all you have to do is put a bare Git repository under your HTTP document root and set up a specific post update hook, and you're done. At that point, anyone who can access the web server under which you put the repository can also clone your repository. To allow read access to your repository over HTTP, do something like this. Interesting. That's all. The post-update hook that comes with the Git by default runs the appropriate command git update server info to make HTTP fetching and cloning work properly. This command is run when you push to a repository over SSH perhaps, then other people can clone via something like git clone HTTPS on the Git project. In particular, we are using the var www/htdocs path that is common for Apache setups. But you can use any static web server, just put the bare repository in its path. The Git data is served as basic static files. See the Git internal chapters for details about exactly how it's served. Generally, you would either choose to run a read/write smart HTTP server or simply have the files accessible as read-only in the dumb manner. It's rare to run a mix of the two services. The pros. We'll concentrate on the pros of smart version of the HTTP protocol. The simplicity of having a single URL for all types of access and having the server prompt only when the authentication is needed makes things very easy for the end user. Being able to authenticate with a username and password is also a big advantage over SSH, since users don't have to generate SSH keys locally and upload their public key to the server before being able to interact with it. For less sophisticated users or users on systems where SSH is less common, this is a major advantage in usability. It is also a very fast and efficient protocol similar to the SSH one. You can also serve the repositories read-only over HTTPS, which means that you can encrypt the content transfer, or you can go so far as to make the clients use specific signals SSS or specific signed SSL certificates. Does anybody have any idea what it's talking about with this whole HTTP and SSH stuff? Another nice thing is that the HTTP and the HTTPS are such commonly used protocols that corporate firewalls are often set up to allow traffic through their ports. The cons. Git over HTTPS can be a little more tricky to set up compared to SSH on some servers. Other than that, there is very little advantage that other protocols have over smart HTTP for serving Git content. If you're using HTTP for authenticated pushing, providing your credentials is sometimes more complicated than using keys over SSH. There are, however, several credential caching tools you can use, including Keychain Access on macOS and Credential Manager on Windows, to make it pretty painless. Okay. Aaron says, like when you log into a website and want it to be HTTPS, your password can't be read over the wire. Oh, okay. So it's just a secure port that you're pushing and pulling data through via HTTPS ports. The SSH protocol. A common transfer protocol for Git when self-hosting is over SSH. This is common. This is because SSH access to servers is already set up in most places, and if it isn't, it's easy to do so. SSH is also an authenticated network protocol because it's ubiquitous. It's generally easy to set up and use. To clone a Git repository over SSH, you can specify an SSH URL like this. Right. Or you can use the shorter SCP-like syntax for the SSH protocol. Cool. In both cases above, you don't specify the optional username. Git assumes that you're the user you're currently logged in as. The pros. The pros of using SSH are many. First, SSH is relatively easy to set up. SSH daemons are commonplace. Many network admins have experience with them, and many OS distributions are set up with them or have tools to manage them. Next, access over SSH is secure. All data transfer is encrypted and authenticated. Last, like HTTPS, the Git and local protocols SSH is efficient, making the data as compact as possible before transferring it. The cons, negative aspects of SSH that it doesn't support anonymous access to your Git repository. If you're using SSH, people must have SSH access to your machine, even in a read-only capacity, which doesn't make SSH conductive conducive to open source projects for which people might simply want to clone your repository to examine it. If you're using it only within your corporate network, SSH may be the only protocol you need to deal with. If you want to allow for anonymous read-only access to your projects and also want to use SSH, you'll have to set up SSH for you to push over, but something else for others to fetch from. The Git protocol. Okay. Finally, we have the Git protocol. This is the special daemon that comes packaged with Git. It listens on a dedicated port, 9418, that provides a service similar to the SSH protocol, but with absolutely no authentication or cryptography. In order for a repository to be served over the Git protocol, you must create a Git daemon expert OK file. That the daemon won't serve the repository without that file in it, but other than that, there's no security. Either the Git repository is available to everyone to clone or it isn't. This means that there is generally no pushing over the protocol. Um, you can enable push access, but given the lack of authentication, anyone in the internet who finds your project's URL could push to that project. Suffice to say, this is rare. The pros. The Git protocol is often the fastest network transfer protocol available. If you're serving a lot of traffic for public project or serving a very large project that doesn't require user authentication for read access, it's likely that you'll want to set up using a Git daemon to serve your project. It uses the same data transfer mechanisms as the SSH protocol, but without the encryption authentication overhead. The cons. Due to the lack of TLS or other cryptography, cloning over the Git protocol may lead to arbitrary code execution vulnerabilities. You should therefore be avoided therefore be avoided unless you know what you're doing. If you run git clone, an attacker who controls your router can modify the repo you just cloned, inserting malicious code into it. If you then compile the code you just cloned, and you will execute the malicious code. Running git clone should be avoided for the same reason. Running git clone on some HTTPS link does not suffer from the same problem unless the attacker can provide a TLS certificate, for example. Running git clone on the project only suffers from this problem if you accept the wrong SSH key fingerprint. Huh. It also has no authentication. Anyone can clone the repo, although that is often exactly what you want. It's also probably the most difficult protocol to set up. It must run its own daemon, which requires xinit or systemd, xinetd, whatever this is, or system ID configuration or the like, which always isn't always a walk in the park. It also requires firewall access to port 9418, which isn't a standard port that corporate firewalls always allow. Behind big corporate firewalls, this obscure port is commonly blocked. All right, 4.2. Get on the server, getting Git on a server. Now we'll cover setting up Git service running these protocols on your own server. Note, here we'll be demonstrating the commands and steps needed to do basic simplified installations on a Linux-based server. Though it's also possible to run these services on Mac OS or Windows servers, actually setting up protocol server with your infrastructure will certainly entail differences in security measures or operating system tools. But hopefully this will give you a general idea of what's involved. All right. In order to initially set up any Git server, you have to export an existing repository into a new bare repository, a repository that doesn't contain a working directory. This is generally straightforward to do. In order to clone your repository to create a new bare repository, you run the clone command with the -bare option. By convention, bare repository directories names end with the suffix .git, like so. Cloning into bare repository myproject.git. You should now have a copy of the directory data in your myproject.git directory. This is a rough equivalent to something like copy of these. Okay, got you. There are a couple of minor differences in the configuration file, but for your purpose, this is close to the same thing. It takes the Git repository by itself without a working directory and creates a directory specifically for it alone, putting the bare repository on a server. Now that you have a bare copy of your repository, all you need to do is put it on a server and set up your protocols. Let's say you've set up a server called git.example.com to which you have SSH access, and you want to store all your Git repositories under the -srv-git directory. Assuming that the -srv-git exists on that server, you can set up your new repository by copying your bare repository over. At this point, other users who have SSH-based read access to the srv-git directory on that server can clone your repository by running git clone on that user's path. If the SSH into a server has write access to the srv git my project directory, it will also have push access. Git will automatically add group write permissions to a repository properly if you run the git init command with the --shared option. Note that by running this command, you will not destroy any commits, refs, etc. in the process. You see how easy it is to take a Git repository, create a bare version, and place it on a server to which you and your collaborators have SSH access. Now you're ready to collaborate on the same project. It's important to note that this is literally all you need to do to run a useful Git server to which several people have access. Just add SSH-able accounts on a server and stick a bare repository somewhere that all those users have read and write access to. You're ready to go, nothing else needed. In the next few sections, you'll see how to expand to more sophisticated groups. This discussion will include not having to create user accounts for each user, adding public read access to repositories, setting up web UIs, and more. However, keep in mind that to collaborate with a couple of people on a private project, all you need is an SSH serve and a bare repository. Small setups. If you're a small outfit and are just trying out Git in your organization and only have a few developers, things can be simple for you. One of the most complicated aspects of setting up a Git server is user management. If you want some repositories to be read-only for certain users and read/write for others, access and permissions can be a bit more difficult to arrange. SSH access. If you have a server to which all your developers already have SSH access, it's generally easier to set up your first repository there because you have to do almost no work, as we covered in the last section. If you want more complex access control type permissions on your repositories, you can handle them with the normal file system permissions on your server's operating system. If you want to place your repositories on a server that does not have accounts for everyone on your team for whom you want to grant write access, then you must set up an SSH access for them. We assume that if you have a server with which to do this, you already have an SSH server installed, and that's how you're accessing the server. There are a few ways you can give access to everyone on your team. The first is set up accounts for everybody, which is straightforward but can be cumbersome. You may not want to run add user or the possible alternative user add and have to set temporary passwords for every new user. A second method is to create a single Git user account on the machine. Ask every user who is to have write access to send you an SSH public key and add that key to the authorized keys within the Git account. At that point, everyone will be able to access the machine via the Git account. This doesn't affect the commit data in any way. The SSH users are connected as does the SSH users you connected as doesn't affect the commits you've recorded. Another way to do it is to have your SSH server authenticate from an LDAP server or some other centralized authentication source that you may have already set up. As long as each user can get shell access on the machine, any SSH authentication mechanism you can think of should work. All right, cool. I didn't really take any notes there, but it's okay. Generating your SSH public key. Yeah, Super Godson, thanks for coming in. Yeah, we'll take a look at some of those free code camp resources and video resources after we finish the book. The book is really not too long. It's only 10 chapters, and we're doing a chapter a day. We're already halfway through. So we'll just get a general sweep through of the book, get a baseline understanding of Git and its uses, and then get some practice via some projects and some videos and stuff like that. Eating crawfish today, distracted funny. That sounds good. Okay. Many Git servers authenticate using SSH public keys in order to provide a public key. Each user in your system must generate one if they don't already have one. This process is similar across all operating systems. First, you should check to make sure you don't already have a key. By default, a user's SSH key are stored in the user's directory. You can easily check to see if you have a key by going to that directory and listing the contents. Okay, so user SSH keys are found within the tilde / dot SSH directory. My girlfriend got back from work and she's a little down.
Close the fucking window.
I'm streaming. No, there's no spiders. Because I opened the window. Oh, a chocolate chip.
You got your crumble, I got my cookie.
Oh, nice. Are we going to the movies?
No.
We're not?
No. But that doesn't mean we're gonna watch that.
No, I'm going to finish this chapter then, if we don't have to go.
You're about to knock a ball onto the floor.
I'm about halfway down. Be done in a little bit.
So where am I supposed to go?
Do you want to come up here? I'm just going to be talking. You want me to go downstairs? You are so drama. Come on in. Water's fine.
Just rest my head on.
We gotta open up this window.
No, stop. Seriously, stop.
There's no spiders.
It's a bad idea.
There is a.
Close it, please.
Okay.
Please don't do this. Please close the window. Turn the fan on.
I'm streaming. Sorry, guys. Got a little bit of a public freak out going on. Freak out. All right. Let's finish this chapter.
I don't know where the clicker
check for current SSH keys first by using cd and ls in your CLI. Let's see if you're in here.
I'm not.
No, you're not.
I know I'm not.
You're funny.
I
Yeah, I did. I was a camp counselor a few years at some camps, like basketball camps and stuff, Tim. So yeah, I've done that a few times. I always thought that I always wished that I had when I was a TA or a lab instructor for the university. I was always jealous because I always wanted a lab instructor or a TA like myself. I was like, man, if I had a TA that was me, then it would be so awesome. But I did a lot for those groups. Okay. You're looking for a pair of files named something like id-dsa or id-rsa, and a common file with a .pub extension. The pub file is your public key, and the other file is the corresponding private key. If you don't have these files or don't have a .ssh directory, you can create them by running a program called ssh-keygen, which is provided with the SSH package on the Linux/Mac OS system, and it comes with Git for Windows. So we'll say the .pub extension or file is the public key, right? And the other file is the corresponding private key.
funny.
You're cracking me up.
Why? Oh.
You're just making me laugh with you're like quiet and like, tiptoeing around. And I was downstairs streaming at the start, and your mom comes down and she's like, "Are you streaming?" I was like, "Yeah." She's okay. She goes over into the kitchen and turns on the vacuum, and then and turns on the stove. They knew I was streaming, but started making a bunch of noise. So I went upstairs.
Yeah.
It was pretty funny. So we'll say if these, check for current by first using the quote ID underscore we'll just say like hashtags and a matching .pub file are the public key this is the .pub, right? So we'll say this is the private key and a matching pub file. This is the public key. If you don't have these files, if these files are not found, run SSH keygen. Perfect. Okay. First, it confirms if you want to save the key, and then asks twice for a passphrase, which you can leave empty if you don't want to type a passphrase when using the key. However, if you do use a password, make sure to add the -O option. It saves the private key in a format that is more resistant to brute force password cracking than is the default normal. You can also use the SSH-agent tool to prevent having to enter the password each time. Now, each user that does this has to send their public key to you or whoever is administrating the Git server, assuming you're on a SSH server setup that requires public keys. All they have to do is copy the contents of the .pub file and email it. The public keys are something like this. For more in-depth tutorial on creating SSH keys on multiple operating systems, see the GitHub guide on SSH keys at this link here. Do you guys have anything you want to add for SSH keys at all in chat? Do you guys have anything to add here? Speak now or forever hold your peace. Okay, let's go next. Get on the server. Get on the server, right? This is setting up the server. Let's walk through setting up the SSH access on the server side. In this example, you'll use the authorized keys method for authenticating your users. We also assume you're running a standard Linux distribution like Ubuntu. A good deal of what is described here could be automated by using the ssh-copy-id command rather than manually copying and installing public keys. First, you create a Git user account and a .ssh directory for that user. Sudo add user git su git cd make dir.ssh and this .ssh. Go into those files or open those files. Next, you need to add some developer SSH keys to the authorized keys file for the Git user. Let's assume you have some trusted public key and have them saved to temporary files. Again, the public keys look something like this. You just append them to the Git user authorized keys file in the SSH directory. Now you can set up an empty repository for them by running git init with the bare option, which initializes the repository without a working directory. Then John, Josie, and Jessica can push their first versions of their project into that repository by adding it as a remote and pushing up a branch. Note that someone must shell onto the machine and create a bare repository every time you want to add a project. Let's use Git server as the host name for the server on which you set up your Git user and repositories. If you're running it internally and you set up a DNS for Git server to point to that server, then you can use the commands pretty much as is, assuming that my project is an existing project with files in it. So this is on John's computer, CDs into my project, creates and initializes the Git repo, adds all the files, makes an initial commit, syncs it to the origin server, and pushes it to the origin master. At this point, the others can clone it down and push changes back just as easily. So then they clone the Git project, and then they CD into it, they go into the README, they fix something, and then they push. With this method, you can quickly get a read-write Git server up and running with a handful of developers. You should note that currently all of these users can also log onto the server and get a shell as the Git user. If you want to restrict that, you have to change the shell to something else in the etc. password file. You can easily restrict the Git user account to only Git related activities with a limited shell tool called Git shell that comes with Git. If you set this as the Git user account login shell, then that account can't have normal shell access to your server. To use this, specify Git shell instead of bash or CSH for that account's login shell. To do so, you must first add the full path name of the git shell command to etc. shells if it's not already there. Now you can edit the shell for a user using the chsh username shell. Now the Git user can still use the SSH connection to push and pull Git repositories but can't shell onto the machine. If you try, you'll see a login rejection like this. At this point, users are still able to use SSH port forwarding to access any host the Git server is able to reach. If you want to prevent that, you can edit the authorized keys file and prepend the following options to each key you'd like to restrict. The result should look something like this. Now, Git network commands will still work just fine, but the users won't be able to get a shell. As the output states, you can also set up a directory in the Git user's home directory that customizes the Git shell command a bit. For instance, you can restrict the Git commands that the server will accept, or you can customize the message that users see if they try to SSH in like that. Run git help shell for more information. Huh. Um, yeah, Aaron, this is definitely a little bit more complicated though than I'm currently than I understand. I'm really not exactly sure of what it's referring to about like shell or these or like server side interactions. I personally have just never dealt with having to ever set up my own like server in any way or interacted with own any like yeah, we've done like like OneDrive servers with Microsoft or like servers at work that you access into, but those are always kind of just done for you, and I've never really had to do this myself, so I'm not really following too closely actually about what all of this is talking about with this shell. Anybody know what this shell is that it's referring to here? Okay, 4 5. Get on the server. Get daemon. And like this get daemon, I have no idea what this is. Hey Marty, welcome in, dude. It might help if you look at it similarly to how you use your Python tools in the command line terminal. Interesting. How you doing, Marty? Welcome in. What you working on tonight? Okay, a get daemon, whatever this is. Next, we'll set up a daemon serving repositories. What is a daemon? It's a background process that runs continuously and independent of user interaction. It's typically used to perform tasks on or provide services without direct control from a user. A daemon is usually started at system boot and runs quietly in the background. It often ends with a D in the name, like SSHD for the SSH daemon, for the web server daemon. Runs it doesn't interact with user often starts at boot time, frees up the terminal console. Basically, useless site to get for now. Yeah, I'm trying to understand. I mean, I think I would like to set up like my own server in terms of like a media hub. Like if I get my when I either get like a house or a long-term apartment or something, I would like to get like not an older model computer, but just like a few years older model computer that has quite a bit of storage space, and I'll upgrade the storage to a lot of memory. And then I would like to set up my own like media hub server where I can sync in like media files and then access them just via over the network, my personal network. Any device that just is on my Wi-Fi can get access to those media files to watch shows or movies and stream them directly from my home side server. So that's definitely something I would like to do and also do on the channel live with you guys, is setting up a home server and getting into that and storing media files, wink wink, like not bruh, like movies or like shows or stuff like that. Like for Node.js, you have to use the Node.js CLI. Git is another CLI tool like Node.js or Python. This is explaining how to set up a server, which is probably won't do very often even in your career. Reviewed OOP, did elite code, then hopped on Minecraft. Nice, Marty. We should play some Minecraft tonight. That sounds fun. Like not maybe in our after hour stream. Not right now though. In a little bit. Maybe in our part two. What OOP principles did you study, and what leak code problem did you do, Marty? We did two. We did number 145 yesterday, post order traversal, and then I did some research, guys, on the one that we looked at before we got off, just to read our next one, which is the intersecting linked list, and I think I know how to solve it. So I kind of got a little bit of a hint on the methodology to solve it, so I think I can do it now. I didn't look at any code, but I just got like a little bit of a hint about a way to go through it. So Aaron, what's the difference between a home lab and like is it not a server, or is it? Jeez, crinkle bag over there.
Exactly.
Chris Crinkle over there.
I haven't had this in a long time.
Yeah, once you get into that, this looking back, reading this will be a breeze. Yeah, I'm sure that when we get into it, we'll have to come back onto this book. Because I mean, like we could set up like our own Git repository for managing all of that media hub, like on that for that home lab, right? And then just basically branch in new content basically that we're wanting to add in or whatnot. I think would be cool. What do you guys think? Yeah, home lab is basically a server at your home. It just isn't your everyday PC. Yeah, exactly. Yeah, cool. Yeah, so my goal is hopefully is when we get some more experience with this is I'll buy like a 500 or whatever, a $600, $700 just a server that we can, or just a PC that'll just remain as a stationary server. We could probably set it up with with Linux, and would have to learn a little bit of Linux and how to do it. And then I would like to make it so that like any person that joins my network or my Wi-Fi can access the contents on that server.
Microscope. Could be you. See, people watch stuff.
Nice.
Sorry.
You'll probably want to use GitHub and have some self-hosted Git on your server and use both as origins. Git SQL. Aaron, do you have any like more information on like servers and like how to set one up? Just reading this book, it's pretty honestly, it's a little bit confusing. All this terminology, all this stuff is pretty new. Firewalls, ports, server, daemon, shells, SSH keys, all this stuff is pretty new to me. It's kind of seems kind of like a foreign language almost. Like IT portion side of things, I'm not really too familiar. Okay, get daemon here. Next, we'll set up a daemon serving repositories using the Git protocol. This is a common choice for fast, unauthenticated access to your Git data. Remember that since this is not an authenticated service, anything you serve over this protocol is public within its network. If you're running this on a server outside your firewall, it should be used only for projects that are publicly visible to the world. If the server you're running on is inside your firewall, you might use it for projects that a large number of people or computers have read-only access to. When you don't want to to add an SSH key for each. And in any case, the Git protocol is relatively easy to set up. Basically, you need to run this command in a daemonized manner. Git daemon re user add r base path equals this path here. The reuse add address option allows the server to restart without waiting for old connections to time out, while the base path option allows for people to clone projects without specifying the entire path. The path at the end tells the Git daemon where to look for repositories to export. If you're running a firewall, you'll also need to punch a hole in it at port 9418 on the box you're setting this up on. Okay, so a firewall basically is a firewall a like a membrane or some sort of barrier that will limit the access to various HTTP ports over the internet, so like you can't access certain sites like at work. Like if your work has a firewall, like if you're trying to access like YouTube or something, or like, you know, a site that they don't want you to see, will their firewall have that port closed for that site via the HTTPS, whatever the IP, what was it that Malin talked about in, it was IP slash TCOS. What was the notes? Um, hmm. Marty said he reviewed Inheritance, just started Leak Code. Yes, I did the two sum today. I did anagram words. Nice. Those ones are fun. The two sum is, you should do the two sum is really good because it kind of was like a first like wake up call into using sets, right? It's like, oh, I have this option of using sets to where I can see if I have a difference already found for corresponding, um, summing of two values in an array. So uh, it really opens your eyes to the abilities that sets have. It's mostly all basic Linux stuff. So it may seem overwhelming now, but it will come with your coding experience. Okay, sweet. Thank you, Aaron. My intro to the terminal was Node.js. Before that, I had to use the Visual Studio, really. Now that C# has .NET Core and it runs on Linux, I use .NET CLI too, so no need to full-blown Visual Studio. Interesting. Firewall has firewall same as your Windows one, not just HTTPS all ports. HTTP is just one port. There are many basic ports. SSH is 22, HTTP is 80, HTTPS is 433. You'll become familiar with these over time. Okay, so when we talked about the internet, right? The internet, you can sync up to an internet via accessing a port, right, through a router, right? And so you're saying that various ports have various securities to them. So HTTP is port 80, but if I want to send data securely, I would need to access port 433. Come on. It's getting darker. Yeah, it's starting to get more and more intense here with stuff. But this is all stuff we need to know. Like, if we're going to be interacting like with products on a company server using Git, then we're going to need to know how to properly navigate through those servers, and so we're not breaking anything. We don't want to look like an idiot and break things on a company's server and get fired or whatnot. So we want to be able to make sure we're accessing the data correctly and managing it correctly, um, and doing things appropriately. Do you guys have any stories or experiences of people at your guys' tech companies or jobs that messed with their servers and wrecked stuff? These are just standards you don't have to set up as the standards. You can run HTTP on port 22. It would just confuse people. Maybe security through obscurity. The firewall is just to open and close them, really. Maybe some more complex rules. I don't know. Okay, so the firewall. Okay, gotcha. Mohan, we'll have to take a dive into Linux together. It seems like it might be inevitable at some point in our programming career here. Okay, let's keep moving here. We're almost done. You can daemonize this process a number of ways depending on the operating system we're running. Since systemd is the most common init system amongst modern Linux distributions, you can use it for that purpose. Simply place a file in this file path with this content. You may have noticed that the git daemon is started here with the git as both group and user. Modify it to fit your needs and make sure that the provided user exists on the system. Also, check that the git binary is indeed located at user/bin/git and change the path if necessary. Finally, you'll run systemctl enable git daemon to automatically start the service on boot, and you can start and stop the service respectively with systemctl start git daemon and systemctl stop git daemon. On other systems, you may want to use the xinetd, a script in your sysv init system, or something else, as long as you get that command daemonized and watched somehow. See, I'm really not understanding what all this stuff is at all. Next, you have to tell Git which repositories to allow unauthenticated Git server-based access to. You can do this in each repository by creating a file named git daemon export OK. The presence of that file tells Git that it's okay to serve this project without authentication. So I'm going to say, please break down this into very, very simple terms. I am unfamiliar with servers and have no experience. What's the big picture? You're setting up a Git server that others can clone your repositories from using the Git protocol. The Git server will be read-only. People can only get your code, not push changes. And it's unauthenticating, meaning anyone who can reach it can clone your repos. You pick a folder to share your Git project. You're choosing a place to store your Git repos like srv/git. Put your Git folders and your repositories in there. Make sure a file exists in each repo to allow for sharing. In every repo you want to share, add this file. It's okay for Git to let people to clone this, okay? Start the git daemon, a tiny program that listens for Git requests. Optional but better, run git daemon automatically in the background. This tells your computer, hey, start the Git server on boot and keep it running. Enable and start the service, or stop it. Open port 9418 if you have a firewall. Git protocol uses port 9418. If your firewall is on, you need to open this port or no one will be able to connect. Testing it. Someone can now clone your repo like this. Place your server.ip in your actual IP or your domain. So, what is the overarching purpose of all this? The whole setup is about making your Git repositories available to others over a network. In other words, you're turning your machine into a read-only Git server. Why would someone do this? Let people clone your code easily. You might want to set up an open source projects. They don't need a username or password. They don't need to generate SSH keys. You can quick and clean and fast. If you don't need people to push your code back to the server, only read it. Your Git protocol is simple, no logins, fast. Too long didn't read. Oh, it's going to give us a Reddit too long didn't read here? Wow, GPT is leveling up here. You're setting up a lightweight Git server so that other people or machines can clone your code quickly and anonymously. It's perfect for public code, internal tooling, or just learning how Git works under the hood. Huh. Only reason I didn't go for cybersecurity. This daemonizing is just meaning it will be running as a background service and potentially starting during server setup. Perhaps you will modify config files and want to restart it. That is the type of action that will be very common. I recommend trying to commit to learning the CLI. I use bash as regular as shell. You can use a CLI text edit like Vim or Nano. Totally agree with ProGit. That's why I teach to my Git learners. I don't know, I don't want to sound like a cop-out, but in general, you should Google individual tasks because you'll be referring to manuals, documentation for standard version. But editing the files, copying moving files. These are the Linux server admin E type things. Honestly, I worked with devs who have several years experience who struggle with basic Git. Interesting. Thank you so much, Aaron, for all that feedback. Okay. I think this might be the last section. Maybe there's one more. Two more. 4.8, 4.9, and then done. 410 is the last one. Okay. Uh, 4.6, get on the server smart HTTP. Okay. We now have authentic access through SSH and unauthenticated access through Git. But there's also a protocol that can do both at the same time. Setting up Smart HTTP is basically just enabling a CGI script that provided with Git called Git HTTP backend on the server. This CGI will read the path the headers sent by git fetch or git push to an HTTP URL and determine if the client can communicate over HTTP, which is true for any client service since 1.6.6. If the CGI sees that the client is smart, it will communicate smartly with it. Otherwise, it will fall back to the dumb behavior. So it is backwards compatible for reads with older clients. Let's work through a very basic setup. We'll set up this Apache as the CGI server. If you don't have an Apache setup, you can do so on a Linux box with something like this. This also enables the mod CGI, mod alias, and mod env modules, which are all needed for this to work properly. You'll also need to set up the Unix user group on the srv git directories to the www-data so your web server can read and write access to the repositories. Because the Apache instance running the CGI script will be, by default, running as the user, next we need to add some things to the Apache configuration to run the Git HTTP backend as the handler for anything coming into the Git path of your web server. If you leave out the Git HTTP export all environment variable, then Git will only serve to unauthenticated clients the repositories with the git daemon export OK file in them, just like the git daemon did. Finally, you want to tell the Apache to allow requests to the Git HTTP backend and make writes be authenticated somehow, possibly with the auth block like this. That will require you to create a a .ht password file containing the passwords of all valid users. Here's an example of adding a whatever that is user to the file. There are tons of ways to have Apache authenticate users and to have them choose and implement one of them. This is the most simplest example we could come up with. You'll also almost certainly want to set up this over SSL so all this data is encrypted. We don't want to go too far down the rabbit hole on Apache configuration specifications since you could well be using a different server or have different authentication needs. The general idea is that Git comes with a CGI called Git HTTP backend. CGI. We'll see. Git HTTP backend. That will, when invoked, will do all the negotiations to send and receive data over HTTP. It does not implement any authentication itself, but that can easily be controlled at the layer of the web server that invokes it. You can do this with nearly any CGI capable web server, so go with the one that you know best. Huh. Hey, Colby, welcome in, dude. How is this a small chapter? How do you compare this book with Shakespeare? It's a relatively small chapter, like compared to the chapter 2 that we read. Um, the sections here aren't very long. It's just dense. Hey, Colby. We're just reading the Git book here. It's just getting into the server stuff just by nature of what it in explaining Git. So, yeah, we are getting some exposure here on the server, but we're not currently, but maybe in the future. Okay. This is 4.6. 4.7. Get on the server. Git web. Now that you have basic read and write and read-only access to your projects, you may want to set up a simple web-based visualizer. Git comes with a CGI script called Git web that is sometimes used for this. So we'll say Git web is a simple web-based visualizer. That comes with Git. If you want to check out what Git web would look like for your project, Git comes with the command to fire up a temporary instance if you have a lightweight web server on your system like LightPD or WebWebrick. On Linux machines, LightPD is often installed, so you may be able to get it to run by typing git instaweb in your project directory. If you're running macOS, Leopard comes pre-installed with Ruby, so WebWebrick may be your best bet. To start instaweb with a non-light PD handler, you can run the HTTP PD option. This starts up an HTTPD server on a port 1234 and then automatically starts a web browser that opens that page. It's pretty easy on your part. When you're done and you want to shut down the server, you can run the same content with the stop option. If you want to run the web interface on a server all the time from your team or from an open source project you're hosting, you'll need to set up the CGI script to be served by a normal web server. Some Linux distributions have a Git web package that you may be able to install via apt or DNF. So you may want to try that first. We'll walk through installing Git web manually very quickly. First, you need to get the Git source code, which Git web comes with, and generate the custom CGI script. Notice that you have to tell the command where to find your Git repositories with the Git web project root variable. Now, you need to make Apache use CGI for that script, which you can add a virtual host. Yeah, I don't know what is going on here. Yeah, Colby, we're trying to at least, but this stuff is getting pretty complicated and I'm not really sure. Again, GitWeb can be served with any CGI or Perl capable web server. If you prefer to use something else, it shouldn't be difficult to set up. At this point, you should be able to visit Git server to view your repositories online. Almost done. Almost there, you guys. Thanks for bearing with me here. We're almost there. 4.8. Get on the server. GitLab. GitWeb is pretty simplistic though. If you're looking for a modern, fully featured Git server, there are 7 open source solutions out there that you can install it instead, as GitLab is one of the most popular ones. We'll cover installing and using as an example. This is harder than the GitWeb option and will require more maintenance, but it's a fully featured option. Installation. GitLab is a database backend web application, so its installation is more involved than some other Git servers. Fortunately, this process is well documented and supported. GitLab strongly recommends installing GitLab on your server via the official Omnibus GitLab package. The other installer options are GitLab Helm chart for use of Kubernetes, Dockerized GitLab packages for use with Docker, from the source files, cloud providers. Administration. GitLab's administration interface is accessed over the web. Simply point your browser to the host page or IP address where GitLab is installed and log into your root user. The password will depend on your installation type, but by default, Omnibus GitLab automatically generates a password for and stores it for at least 24 hours. Follow documentation for more details. After you've logged in, click the admin area and log an icon in the menu at the top right. The admin area item in the GitLab user. Okay. Users. Everybody using the GitLab server must have a user account. User accounts are quite simple. They mainly contain personal information attached to login data. Each user account has a namespace, which is a local grouping of projects that belong to that user. If the user Jane had a project named that project's URL would be server Jane project. You can remove a user's account in 2 ways. Blocking a user prevents them from logging into the GitLab instance, but all of the data under that user's namespace will be preserved, and commit signed with that user's email address will still link back to their profile. Destroying a user, on the other hand, completely removes them from the database. Okay, so we'll just say GitLab here, and we'll say blocking, and then we'll say destroying. Really need it. Groups. A GitLab group is a collection of projects along with data about how users can access these projects. Each group has a project namespace the same way that users do. So if the group training has a project materials, its URL would be this. Each group is associated with a number of users, each of which has a level of permissions for the group's projects and the group itself. These range from guests to owner. The types of permissions are 2 numbers to list here, but GitLab has a helpful link. Projects. A GitLab project roughly corresponds to a single Git repository. Every project belongs to a single namespace, either a user or a group. If the group project belongs to a user, the owner of the project has direct control over who has access to the project. If the project belongs to a group, the group's user level permissions will take effect. Every project has a visibility level, which controls who has read access to that project pages and repository. If a project is private, the project's owner must explicitly grant access to specific users. An internal project is visible to any logged in user, and a public project is visible to anyone. Note that this controls both Git fetch access as well as access to the web UI for that project. Hooks. GitLab includes support for hooks both at a project and system level. For either of these, the GitLab server will perform an HTTP post with some descriptive JSON whenever a relative event occurs. This is a great way to connect your Git repositories and GitLab instances to the rest of the development automation, such as a CL server or CI server, that chat rooms, or development tools. basic usage. The first thing you want to do with GitLab is to create a new project by clicking the plus icon on the toolbar. You'll be asked for the project's name, which namespace it should belong to, and the visibility level it should be. Most of what you'll specify here isn't permanent. You can change the settings. Once the project exists, you'll probably want to connect it to a local Git repository. Each project is accessible over HTTPS or SSH. So this is like GitHub then, but a different service. Either of which can be used to configure a Git remote. The URLs are visible at the top of the project's homepage. For an existing local repository, this command will create a remote named GitLab to the hosted location. If you don't have a local copy of the repository, you can simply do this. You can clone it from the server. The web UI provides access to several useful views of the repository itself. Each project's homepage shows recent activity, and the links along the top will lead you to views of the project's files and commit log. Working together. The simplest way of working together on a GitLab project is by giving each user direct push access to the Git repository. You can add a user to a project by going to the members section of that project settings and associating the new user with an access level. The different access levels are scuffed a bit in groups by giving a user an access level of developer or above, and that user can now push commits and branches directly to the repository. Another more decoupled way of collaborating is by using merge requests. This feature enables any user that can see a project to contribute to it in a controlled way. Users with direct access can simply create a branch, push commits to it, and open a merge request from their branch back into master or any other branch. Users who don't have push permissions for a repository can fork it to create their own push commits to their copy and open a merge request from their fork back to the main project. This model allows the owner to be able to be in full control of what goes into the repository and when, while allowing the contributions from untrusted users. Merge requests and issues are the main units of long-lived discussion in GitLab. Uh, each merge request allows a line-by-line discussion of the proposed changes, which supports a lightweight kind of code review, as well as the general overall discussion thread. Both can be assigned to users or organization milestones. This section is focused mainly on Git-related features of GitLab, but as a mature project. It provides many other features to help your team work together, such as project wikis and system maintenance tools. One benefit to GitLab is that once the server is set up and running, you'll rarely need to tweak a configuration file or access the server via SSH. Most administration and general usage can be done through the in-browser interface. All right, last section here, 4.9. Third-party hosted options. If you don't want to go through all the work involved in setting up your own Git server, you have several options for hosting your Git projects on an external dedicated hosting site. Doing so offers a number of advantages. A hosting site is generally quick to set up and easy to start projects on, and no server maintenance or monitoring is involved. Even if you set up and run your own server internally, you may still want to use a public hosting site for open source code. It's generally easier for the open source community to find and help with. These days, you have a huge number of hosting options to choose from with different advantages and disadvantages. To see an up-to-date list, check out the Git hosting page, this here. So I'm going to go copy this. Hosting options. We'll cover using GitHub in detail in GitHub, as it's the largest Git host out there, and you may need to interact with projects hosted on it in any case. But there are a dozen more to choose from, so you should not want to set should you not want to set up your own Git server. And summary. You have several options to get a remote Git repository up and running so that you can collaborate with others or share your work. Running your own server gives you a lot of control and allows you to run the server within your own firewall, but such a server generally requires a fair amount of your own time to set up and maintain. If you place your data on a hosted server, it's easy to set up and maintain. However, you have to be able to keep your code on someone else's servers, and some organizations don't do that. It should be fairly straightforward to determine which solution or combinations of solutions are appropriate for you and your organization. Woohoo! Nice. We are done with chapter 4. Um, what is Git blocking? Git blocking is an official Git term, but depending on the context, if you're trying to so let's go back to 4.8. I talked about blocking here. Blocking users. Prevents them from logging into the GitLab. But all the data under that users destroying a user completely removes them from the database and file system. All data in namespace is removed. Yeah, Colby, that's probably true. The book is giving us a little bit more detail than we're probably needing, but it's okay. We'll keep so distributed workflows. That was just server. That was just that one chapter. So now we have distributed workflows. So this should be good to continue on and working collaborating together. All right, you guys. So tomorrow we will go ahead and start and finish chapter 5 of Git for distributed workflow. Distributed Git is chapter 5. And then so right now we finished chapter 4. So let's go ahead and push this up. Git add. Git add. Git commit. Finished chapter 4. Push that up. Cool. All right, sweet, you guys. Thanks so much for joining me here while I read and finished chapter 4. I'm in my little bit of a different setup than normal. I'm visiting my girlfriend this weekend at her place rather than her coming to mine, like typical, or our place. Um, she just stays with her family during the week for work purposes and stuff. But yeah, it's just visiting here in this different setup. Thank you guys so much for being here and joining me. I will potentially come back later, probably pretty late tonight if it is going to happen for a after-hour stream where we'll work on the project and just hang out. But I'm gonna sign off here for right now for the next maybe 2 hours or so, and then maybe we'll come back and do an after-hours um, work session on the project, the Small Business Manager. So for those that are new here, we're working on the Small Business Manager project. This is our CS50X final project where we're building a complete graphic interface into Kinter using Python entirely from scratch, where we're taking items, expenses, and transact those items to populate and generate income statements. Thank you guys so much for being here and joining me today. I'll potentially be back a little bit later this evening for an after-hour session, so join the Discord link down below to get an announcement for if I'm going to go live again, but just be on the lookout for a announcement via the YouTube. Anyways, guys, thanks so much for joining me. It's awesome to hang out with you guys. Please let me know if you have any like resources or information that we can get some practice with Git. I really would like to get some actual practice using it. Yeah, we currently use it to manage our project right now, but I need to get more practice with like branching and merging. I've never ever done that before. And also more information along this server information. I personally would like to set up my own home lab server where people that come onto my Wi-Fi network can access all of my data via like media sources and files like movies or shows or things like that that I collect over time and I burn to, the disk or whatnot. So please let me know if there's any resources out there you guys have and provide them in the Discord. But I'll let you guys know if I'm back later in the Discord, and I'll see you guys later tonight. Bye, guys. Thanks so much for being here. It's super fun. See you, Aaron. See you, Marty, Colby, Tim, Mahan. You guys are awesome. Thanks so much for coming in and hanging out with me again. Super God, Distracted Funny, Smoking Noir. You guys are the best. Thanks so much for always coming in here night in, night out. Leave a thumbs up if you're here, and I'll see you guys later. Bye, guys. Talking self-hosted things and hosting media would be a plex.
Are you
Interesting.
still on?
All right. I'm signing off, guys. Bye.